Okay, so we have the ODE, the ordinary differential equation. And again, it's the two major discussion on ODE, will focusing on the initial value problems and as well the boundary value problems. So, say difference aning duha. The initial value problems, or also called the IVP, I believe you are already kind of very familiar with this one because majority of the calculations that we have, especially when dealing with differential equations, always has initial value. So, unsay pasabutan ning kuan IVP from the word initial value. So, in a differential equation, unsay nani, the initial values are given. Wala na siya. For example, at y naught, when x is 0, y is equal to, let's say, 5. Or when x is 0, y prime is equal to 1. So these are problems where the initial values are given. Unsay kalainan with the boundary value problems. In the boundary value problems, no, from the word boundary, so may pasabot ana. Ang naa niya is ang start and end. No? The start, the beginning, and the end were given. So for example here, we have a boundary condition. So makaibalutag boundary condition kung ang beginning ang end ang gihatag. For example, gihatagan kag initial value, isa ka initial value, and then we have the end nga value or katong katapusan nga condition. We call this boundary value problems. Again, in the IVP, we have two initial conditions. In the BVP, we have one initial condition and one final or end condition. Munang boundary kay isig katumoy man siya. So we call that the boundary value problem. So karon si initial value problem and si boundary value problem, non-philailay nga method to solve or to estimate in the sense of numerical analysis the solution of these ODEs. So unsa man tong unsa man tong mga methods no involved. So mo ni sila. In the initial value problems, actually we have several methods, but we are only going to discuss three numerical methods. These are the Euler's method, or also called as the Euler's explicit method or the standard Euler's method. And then we have the modified Euler's method, or also called the Euler's predictor corrector method. And then we have the Runge-Kutta method in solving or in approximating or estimating the ODEs with initial values. For the boundary value problems, no, katong naay end-to-end nga condition nga gihatag, you're going to use the shooting method and the finite difference method to approximate the solution of the given ordinary differential equation. So in the initial value problems, no, when it is impossible or undesirable to find the exact or analytic solution, we can use the numerical methods. So in the IVP, this is made up of two components. We have a mathematical model, of course, in differential equation, in the form of differential equation, such as this one, dy over dt is equal to f of ty, where t is greater than 0. And then we have also an initial value, that is the IVP, given at some value of the independent variable, such as y of 0 is y naught. The numerical solution to this IVP is a sequence of numbers. So we have here a graph. So we have a curve, no? And then as you can see, not diri gyapon nagyapon tay mga step size diri applicable. This is equidistant. So man siya nga at T1, that is AH, at T2, that is 2H, T3 is at 3H, or pwede po na siya X1, X2, X3, so on and so forth. So we have the initial values, given nga initial value, and then the rest of the points will be estimated. So this is the exact solution. We have the initial value and the approximate solution of the um, ordinary differential equation. And then each of these kani siya, has a step size h or delta x that are of equidistant. They have the same distance. So, so in the next discussion, in the next video, we are going to tackle the very first method to estimate or approximate the solution of the ODE.